Okay, so now let's look at number 3. We're going to start seeing some exponential decay problems. So number 3, y equals 1/2 to the x power. Because your base is less than 1, that's telling you it's exponential decay. Okay, and we're going to make a table before we graph it. And on your table, let's just let the calculator tell us what our table is. Okay, so go to y equals on your calculator. Put in 1/2 to the x power. You have to put that fraction in parentheses or else it doesn't give you the right answers. So parentheses, 1/2, parentheses, and then put a caret and then your x. So the caret sign is on the right side underneath the arrows. So parentheses 1/2, close your parentheses, and then caret x. And we want to find when x is -2, -1, 0, 1, 2. Okay, we're going to plug in those x values, or let the calculator do it, I'm sorry. Okay, so when x is -2, it says my y is 4. -1, 2, 0, 1, 1 is 0.5 or 1/2, and 2 is 0.25 or 1/4. Okay, and then we're gonna graph that. Okay, so -2, 4, -1, 2, 0, 1, 1/2, 1.5, 2 1/4. So, oh, my graph looks bad. Yours probably looks a lot better. But you can see that exponential decay curve. Your curve is decreasing from left to right. All right, so now let's answer the questions. My domain. This graph goes to the left forever and ever and to the right forever and ever. So it's going to go from -infinity to +infinity. We're all real numbers. Your range is from the lowest to the highest, and my lowest is 0. Even though it doesn't touch it, or it shouldn't, my graph doesn't look good. But it will go from 0 to infinity. That 0 will have a parentheses, okay, or you could say y is greater than 0. For your end behavior, as x approaches +infinity, we want to figure out what the y approaches. And as x approaches -infinity, what is my y approach? Okay, so look at your graph. As x gets bigger, this time my y approaches 0. It gets closer and closer to that asymptote. And as my x approaches -infinity, as my x goes towards the left side, the smaller numbers, my y is getting bigger. So as x approaches -infinity, my y approaches +infinity. Okay, and then my y-intercept is 0, 1. And my asymptote is where y equals 0. Okay, so that's number 3. Okay, so I'm going to let you guys try the next 2, and then we'll check. So I'll give you a little bit of time on number 4, and then we'll check, and then I'll give you a little bit of time on number 5, and then we'll check. Okay, so on your table you should have gotten the points. -2, 2.25, -1, 1.5, 0, 1, 1.67, 2.44. Okay, so whenever you plot this graph, you should have got an exponential decay. Okay, a curve that's decreasing. On your domain, it goes to the left for forever and to the right for forever. So negative infinity to positive infinity, or all real numbers. Your range goes from 0 to infinity, or y is greater than 0, either one. As x approaches positive infinity, my y gets closer and closer to that asymptote, so 0. And as x approaches negative infinity, my y gets bigger and bigger. It gets closer to positive infinity. Should have gotten a y-intercept of 0, 1, and an asymptote at y equals 0. Okay, so that's number 4. Okay, go ahead and do number 5, and then we'll check. Okay, so in this one, you should have gotten exponential growth. And a lot of people are confused about why it's growth and not decay whenever you have a fraction here. And you have to think about what that fraction is. 5 over 2 is actually the same thing as 2.5. So is your base greater than 1? And it is. It is greater than 1. So this is actually exponential growth. So you can't necessarily always say, okay, if my base is a fraction, it's going to be decay. Because you can have an improper fraction that gives you a base greater than 1. So you should have gotten the points negative 2.16, negative 1.4, 0, 1, 1, 2.5, 2, 6.25. Okay, so you have your exponential growth. Your domain would be all real numbers again. Your range goes from 0 to infinity, or y is greater than 0. As my x approaches positive infinity, as it gets bigger, my y gets bigger, so it approaches positive infinity. As my x approaches negative infinity, as my x gets smaller, my y gets closer to 0. Then my y-intercept is 0, 1, and my asymptote is y equals 0. It's a horizontal line. All right, now look at your worksheet. I want to go over, let's see. I want to go over the top part where it has some notes on it, and then one of the first sections, equations. So let's look at the top part where it has the notes. It's talking about transformations, and this is what we've done before. Okay, it has an equation on the left side, f of x equals a times b to the x minus h plus k. All right, and then to the right side, it says, okay, h is what kind of shift? So look at h in that equation. If we have a number up here with x and the exponent, how is this going to shift? And hopefully you remember it shifts either to the left or to the right if it's in that exponent. So you can put left or right. The better way to say it is that this is a horizontal shift. Okay, it's either going to move to the left if it says x minus a number. Remember, it does the opposite. Or it's going to move to the right. I said that wrong. If it says x minus a number, it'll move to the right because it's the opposite. I'm sorry. Or if it says x plus a number, it'll move to the left. Okay, then, well, and it has it on there. I'm sorry. The positive shifts it to the left. And the negative, if you have x minus a number, it's going to shift it to the right. Okay, the next part wants to know what kind of shift k has. Okay, so if you look at your equation, your k is the number at the end. So if we have plus a number at the end or minus a number at the end, you need to know how that moves. So it's going to move it either up or down, if you remember. And the better way to say it is that it gives you a vertical shift, up or down. All right, so if you have plus k at the end, it's going to shift it up. If you have minus k at the end, it's going to shift it down. Okay, the next one, if a is the function is blank. So look at a. A is that very first number. So if my very first number is negative, remember it's going to flip it upside down. And we say, we've said before it's reflected over the x-axis. That's what's going to happen. The function is a reflection. Across the x-axis. So this is when your a is negative. It's going to reflect over the x-axis. Okay, next one, when the absolute value of a is greater than 1, it's going to give you a vertical stretch. And when a is between 0 and 1, it's going to give you a vertical compression. And up to now, we've just said it stretches by a factor of 3, or it stretches by a factor of 1/2. But technically what's going on, if you have a number bigger than 1, it's going to stretch it vertically and be a little bit steeper, depending on the number. And if you have a fraction there, it's going to compress it and be flatter than a bigger number. So the better way to say it is a vertical stretch or a vertical compression. All right, and then on number 1, the directions say, part A, identify the parent function, and B, describe the transformations. Okay, so number 1, we have f of x equals 3 to the x power plus 5. So my parent function is where I have the same base, but all I have is an x and the exponent. It's pretty stripped down and just plain Jane 3 to the x power. You just want to make sure you have the same base. If you don't have the same base, it's going to look a lot different. And we saw that in the notes, the difference between 2 to the x power and 3 to the x power. Okay, so part A, my parent function is 3 to the x power. Part B, you're going to say how this graph moved from the parent function. So what did the plus 5 make it do? And it shifted it up 5. Okay, so that's what you're going to do on 1 through 4. Tell me what the parent function is. So it just has the same base to the power of x. And then tell me how the graph moved, how it transformed. The other problems, 5 through 9, you're going to use the calculator to make your table, make your graph, and then answer the questions just like the notes. All right, and you'll have a good day.